Hey, what's going on, folks? It's Mike here, and welcome back to my Modern C++ series. In this episode, we're going to be talking about constinit. So if you watched the previous lesson with consteval, this plays nicely with it, except constinit is for variable declarations at compile time. So again, we're adding a little bit more power with C++20 with constinit. So let's go ahead and check out CPP reference here to see where exactly this is defined. Under declarations here, we're going to go ahead and click on this, and let's go ahead down here. And again, we can see that constinit, which is the star of today's show, is what we're going to be taking a look at. So again, you can kind of see that consteval and constinit are grouped in the same box since they're in the C++20 features. And again, it's giving us, as far as constexpr, for those of you who are familiar with it, this sort of guarantee for variable definitions to be evaluated at compile time. So constinit specifier, it's only allowed in a declaration of a variable, so you're not using this with functions. That's what consteval is for, which was, again, in the previous video. And you can only use this with variables that are static or thread storage duration here. And at most, one of constexpr, consteval, and constinit specifiers are allowed. So again, constexpr is sort of the maybe compile time, maybe runtime thing that you have. Consteval is the must evaluate this function at runtime, and constinit is the must evaluate this variable at compile time. So let's go ahead and just keep it open and have a look here. And you're actually going to notice that what's kind of interesting is constinit are things that must be known at compile time. So things like character strings, for instance, these are allocated statically within your executable. Maybe we'll look at an example of that. That might actually be interesting to peek at. But otherwise, you make everything static. Okay, so let's go ahead and take a look here at how this works here. Let's go ahead and just kind of open that there. There we go. And what I'm going to do for this example here is let's just go ahead and do a few examples here. Let's do consteval, which we looked at last time. Let's do one with constexpr as well. And I'm just going to write some functions called get value constexpr. And let's just, this is going to be a simple function here, return 42. Let's see, consteval, get value consteval. Let's return 43. And then let's also do let's do get constexpr 2 here. Let's just return some value here, okay? This will be 42 plus n, okay, just to have some different use cases. So this must be evaluated at compile time, maybe evaluated at compile time, okay, with constexpr. And this one's also going to be a maybe evaluated at compile time, okay? Just so you can see here, keep those functions straight here. Now, as far as our variables here, let's go ahead and use constinit here. Let's just make it a integer. I'll just call it variable. Let's just call it var1 or something like equals 7 here. Okay, let's try to just compile this and let's see what happens here at this point. Make sure we didn't make any silly typos. And immediately we did make one silly typo on purpose because I wanted to show you the compiler error, I promise. And it tells you constinit can only be applied to a variable with static or thread storage duration here. Okay, so I do need to make this static here. Okay, so let's go ahead and just open this up here. I think we're going to do a little bit more of a exploration here. So what I need to do here is make this static. And let me do these in the right order here. Static int here. Okay. So now this compiles and runs just fine here. Now, if I run a tool, let's see if nm will do the trick for me. Which nm basically just shows you the symbols. Nm here lists symbols from an object file. So somewhere here, if I look carefully, I should have var1 here. I might have to grep for it or write it out to vim or something. Let's see here if we can see vim. The actual var1. Yeah, of course it is right here. And it's in the data section here, var1. Now the name is mangled. Sorry about that. I mean, that's just C++'s rule. So it's part of main. That's where this static variable is. If I move it out, actually, let's move it out of main here, just so you can see. Let's get rid of the mangling. So we're going to recompile, re-look at the thing in nm here. And now I see var1 outside here, right? So that's why the name, the function in which the static thing was found. But the whole point of this, or what I'm just trying to show you, and actually I could probably show you Let's just dump out the assembly. Ooh, we haven't done that in a long time. This series here, but let's look at main.s here. And right, I can see in the .data section where var1 is here, okay? And I need 4 bytes for it. Okay, so again, I've got all that sort of set up here. So again, static, that keyword, that's just telling you, hey, this thing is part of the executable, okay? So if I do again, I'm just gonna keep showing you this in a bunch of different ways here. If I look at the program here with this static, let's see, 16104, that's the byte size here. Oh, this is perfect. So let's comment this out here. And I know if an integer is 4 bytes, I should see this number go down, okay? Let's go ahead and recompile this. Okay, if I run it, it's not gonna do anything. But if I do ls of my program here, yeah, it's a tiny bit smaller, right? Because the text section got smaller. Well, I guess I got, here, let's try to do this as a, here, let's get rid of static here. Let's just have this be a global variable here. That's the real test here, okay? And then you'll understand why I'm excited about this. Let's see here. Okay, so a global variable, that is something that we have allocated here. And then let's move it back here. Okay. Here, let's do the test here. So with just a stack allocated variable, that's the size, okay? Because it's gonna be on the stack, right, as needed. A static variable, and if I run this here, you will see that there is some allocation for it. And this also holds if I make this a global variable, right? Because global variables, again, are executed with the, or are part of the program here, right? So this is the global version. This is the static version here. I guess there's a little bit more information somewhere. And then the stack allocated version, right? It's just part of the stack when we need it here, okay? Part of the program code. So you can see the little variations as far as where the storage is. So again, let's go back here in our time machine. This is what we need here. Constinit, we must have storage for it, right? We can't use the stack version, right? So we need, one of these versions basically. Yeah, that's the basic idea. Now I wonder actually, and this is kind of interesting here, because I know if I have a global variable, can I make it constinit? Let's see here. Yes, I can, right? I have some storage for it somewhere, and it's evaluating to a known value at compile time, the value 7 here, okay? Hopefully that kind of clears things up on the storage duration and that static key. But if I make it a stack allocated value, I gotta make sure that we have some memory for it, part of the executable. Okay, so that's why we do static there. Okay, so hopefully that makes this less scary when you see 3 keywords in front of just a variable that you want to assign 7. Static means, yeah, we need some storage for this. Constinit says we must be able to evaluate this at compile time. Okay, now let's get into that must part here. Let's create some more variables here. And let's start assigning them. Let's say get value expr, get value expr2, and then I'm going to pass in a 7 here. And let's go ahead and do this one here, get consteval, okay, with no parameters. Okay. Now this is a good little test here before I run this. If you want to pause the video and see, is this going to give me any errors? Do I know, am I able to compute these values at compile time here? All right, if you pause the video there, hopefully I gave you long enough time. Otherwise, hit spacebar really quick. But let's go ahead and compile this. And, oh, it works. Okay, so I know all these values at compile time. No problem, right? I can figure out, the compiler is smart enough to plug in 7 here and kind of fold this here. So, yeah, this is all good to me here. Now, let's go ahead and say... let's try to make this a little bit more complicated. Let's go ahead and add some variable here, n. Ooh, okay. And let's go ahead and do experiment number 5 here. And this time we're going to pass in n here. We're going to see how smart the compiler is here. Let's compile it. Yeah, okay. Now this is going to start causing problems because say, hey, this value is not constant. We're not able to basically propagate this value forward because n could change somewhere. And it's not that we want to just look at the next line of code here. It's that, right, the actual logic of this program could be multi-threaded and n is being shared somehow or whatever, right? Again, maybe with a real aggressive compiler where you're guaranteeing single thread execution and all this sort of stuff, you could prove this. But again, we don't know that n is const. So how can I work with this constinit thing? let's make the value const here. Ooh, still can't do it, right? Because it's uninitialized, right? So if I hit n equals 7 now, let's see if we get a little bit closer. Yeah, still doesn't like that here. Now I'm breaking both rules here, right? Can't change a read-only value here. But now I should be able to say const int. This is okay now, right? So I need a const value here to pass into this constexpr thing and not have any problems. Now, you can use consteval and constinit things in pairs, right? Because this value must be known and all of these functions must be known here. Okay, so consteval is a good thing to use with constinit, okay? So let's go ahead and kind of summarize this a little bit. Just to, again, show what's going on here. Can I still mess with var? Can I still mutate it? Is the question. And yes, I can here. Okay. So same thing if you watch the consteval video. Constinit has nothing to do with like saying, hey, I can't mutate var5. Okay. So let's kind of summarize these things here. So constinit added in C++20 only applies to variables, pairs well with consteval, sometimes works with constexpr if we can prove if that const expr expression evaluates at compile time, provably by the compiler. Okay, so those are the things that we want to keep in mind here. All right, let's go ahead and hang on to those. Let's see. And again, the variable must be initialized at compile time. That means, okay, we need space for it. So we need variable to be global or static. Okay, and we saw that with a few examples with the nm tool here. If you don't have nm, I think O-tool, if I remember, is on Mac. Sometimes I use objdump. -t will get me the table here. Objdump there, spelled properly. And if you look at this, you can dump out the data section or something and find all those variables here. nm is actually pretty clean here. Let's see if we can see all of our symbols, right? var1, var2, var3, var4, etc. But that was the basic idea here. So hopefully that explains constinit. Again, it pairs well with consteval. These are nice features, again, in C++20. So if you can use them, probably a good idea to use them. Other languages like in D use like immutable and have those types of things too, which is also kind of nice. So you have like these stronger guarantees and you don't need as many keywords. But in C++20, this is what we get here, constinit and consteval. There we go. So folks, hopefully you enjoyed this lesson. That was constinit. These things were, they seemed scary to me for a long time. And then now we have them here. I guess the last thing that I want to do here, just to maybe just to demystify, why does this example work here? And maybe this is a reminder for some of you folks. Let's actually do it here. Here, const char star. Let's call it get string. Return hello subscribers. How about that? Make sure you subscribe. All right, that's my pitch. All right, that's all we care about. But let's go ahead and do const init static. This will be a char string. var6 here, get string. Okay, will this work? Okay, let's go ahead and see. And if you paused it, let's go ahead and run it. Let's see. I have to make this. Here, let's just do a char string here. Okay, still complaining. Here, I do need to make it const. Okay, so that part's good. That part I'm confident about here. Constinit var6 does not have a constant initializer here. Ooh, yeah, because we need to match this char star thing here. All right, to be a constant variable here. Const. Let's see here. What else is it complaining about? Well, I guess it doesn't know. Let me back us up here a little bit. I mean, this example is kind of doing a nice little thing here where it's saying, I I mean, yeah, that's actually a cool example. So it's giving us the constexpr thing here, where it's going to return, yeah, true or false here. I see. Let's see actually if I can coax this into, if I say that this is just a constexpr. Let's see if that's enough to get it to go. Yeah, that's enough. I mean, the other example is a little bit, I mean, we still need to give hints, right? In our compiler, right? These are our hint, almost like annotations here. Let's see, actually, I can probably get rid of this const then. Let's see here. Well, let me do that. It might complain a little bit. Yeah, it's going to complain. Yeah, because it's returning a const string. But this is still allowed here, just in case you were, concerned about that example here, because I think nm will maybe give me, will it give me the symbols? No, it won't. I think I'll have to actually do the little assembly dump here, just so that you can see here in the main, main lowercase s, hello subscribers should be stored somewhere, right? So it has an address, so it is assignable by things that are constinit, because this thing's not going to change. It's known at compile time that we're just retrieving the address to this string here. We know the size, and so on. Okay, so just in case you were confused by that example, that's the idea. But I mean, really, constinit is not something to be scared about, right? This is a feature that can be explained in a few seconds. Just wanted to give you all the examples. Just has to be something that's known at compile time, and you put it on variables, and it works well with consteval. Okay, so anyways, happy we did that little detour and kind of proved it to ourselves how things worked. And for this, and if you missed the lesson on consteval, you can again check those out either in the YouTube playlist. You can check it out on course.mshot.io. Just go ahead and wherever you want to learn, go ahead and learn. So anyways, folks, hopefully that's good stuff. Hopefully just demystifying some of the, useful features that have otherwise been added in C++ 20. Again, they're not things to be scared of, just things that, well, you need to know how they work. So let me know if you're using constinit. Let me know if you're seeing improved, speeds in your application, or if your executable sizes are growing really large now that you have all this compile time stuff that you can do. I'd be really curious to hear if you have some good use cases. But with that said, feel free to post any questions otherwise, and I'll look forward to seeing you in the next one.